Hello students, in last lecture we have discussed decision support system, and in this structure we already discussed DSS and the concept and philosophy. In DSS we learned that a decision support system is an interactive software based system designed to assist decision makers in making informed and data driven decisions. DSS combine data, sophisticated analytical models, and user-friendly software to support semi-structured and unstructured decision-making processes. They are widely used in business, healthcare, finance, and various other fields to enhance the quality and efficiency of decisions. After that, we learned types and examples, and we also discussed deterministic system, and in this type of system we studied it operates under predictable and predetermined rules and conditions leading to a specific outcome without randomness. In a deterministic system, the same initial conditions will always produce the same outcome. Also, there is no element of chance or uncertainty in the system's operations. Example include traditional algorithm, mathematical models in physics, and simple mechanical systems. After that, we discussed artificial intelligence system. In AI system, we studied this type of system refers to a system that can perform tasks that typically require human intelligence. These tasks include learning from data, recognizing patterns, making decisions, and understanding natural language. There was key characteristics of AI system include like learning ability, adaptability, autonomy, complex problem solving, right? And few examples was include autonomous vehicle, recommendation systems, natural language processing systems, and advanced robotics. So all in all, till yet we studied that while deterministic systems are rule based and predictable, AI systems are characterized by their ability to learn, adapt, and make decisions in complex and dynamic environment. Today we will learn that how many types of AI system have. So AI system can be categorized on their capability into three main types. First is artificial narrow intelligence, which is called ANI. Second, artificial general intelligence called AGI, and ASI, which is also known as artificial superintelligence. Each type represents a different level of AI sophistication and functionality. If talking about ANI, also known as weak AI, designed to perform specific tasks. These systems operate within a limited context and cannot perform beyond their predefined functions. For example, voice assistants like Siri by Apple, Alexa by Amazon, Cortana by Microsoft are prime example of ANI. These assistants can perform tasks like setting reminders, answering questions, and controlling smart home devices. Another example is image recognition. This type of software application that can identify objects, people, or scene in an image, such as facial recognition systems used in security and social media platforms. Another example is recommendation algorithms, like systems those used by Netflix and Amazon to suggest movies or products based on user preferences and past behaviors. If we talk about its characteristics, so ANI excels at its designated task but lacks general intelligence. It cannot learn or adapt beyond its initial programming. These systems rely on large amount of data to learn patterns and make decisions. Techniques such as machine learning and deep learning are commonly used. ANI operates within predefined boundaries and cannot generalize knowledge from one context to another. If we talk about AGI, or we can say Artificial General Intelligence, it is also known as strong AI. It refers to systems that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks, similar to human intelligence. For example, hypothetical systems. In AGI systems, they are currently theoretical and have not yet been realized. They would be capable of performing any intellectual task that a human can do, such as reasoning, problem solving, and abstract thinking. If we talk about its characteristics, so AGI systems can generalize knowledge and apply it to different situations. They are not limited to specific tasks and can adapt new challenges. AGI would possesses human level cognitive abilities, including understanding complex concepts, learning from experience, and making decisions based on incomplete information. These systems would be capable of performing a wide range of tasks, from scientific research to creative endeavors, without needing to be specifically programmed for each task. If we talk about artificial superintelligence, or we can say ASI, it refers to AI systems that surpass human intelligence in all aspects, including creativity, problem solving, and emotional intelligence. For example, ASI is a concept that has not been realized. It represents a future stage of AI development where machines would outperform humans in every field. Talking about its characteristics, so ASI would be capable of outperforming humans in every intellectual and practical task. This includes not only logical reasoning and problem solving, but also creativity and emotional understanding. ASI systems would have the ability to improve themselves autonomously, leading to rapid advancements in their capabilities. The development of ASI could lead to significant advancement in technology and society, but also poses challenges and risks such as ethical consideration and control issues. AI systems can be categorized based on their functionalities into four main types. The first one we have reactive machines, second, limited memory, third, theory of mind, and fourth, self aware AI. Each type represents a different level of AI capability and complexity. Let's talk about reactive machines. So, reactive machines are the most basic type of AI systems. They can only react to specific inputs and do not have the ability to perform memories or use past experience to influence future decisions. For example, IBM's Deep Blue. This chess playing supercomputer defeated world chess champion Garry Kasparov in 1997. Deep Blue could analyze the chessboard, recognize the pieces, and even predict the next moves for itself and its opponent based on pre-programmed rules. Talking about its characteristics, so this type of AI system are designed to specific tasks and provide consistent outputs for given inputs. They cannot perform duties other than those they are programmed for. These systems do not learn from past experiences. They operate solely based on the current input and predefined rules. Reactive machines will react the same way to the same situation every time, making them reliable for tasks that require consistent performance. Talking about limited memory, so this type of systems can use past experiences to perform future decisions. They have a limited memory that allows them to learn from historical data. For example, self-driving cars. These vehicles use data from previous trips to improve navigations and safety. They can learn from past interactions to make better decisions on the road. If we talk about its characteristics, so these systems can store past data and use it to make predictions and decisions. This allows them to improve over time based on previous experiences. While they can learn from past interactions, their memory is not extensive and is typically limited to specific tasks. By learning from historical data, these systems can make better decisions over time, enhancing their performance in their designated tasks. If we talk about next type of system is theory of mind. So theory of mind AI is still in the research phase and aims to understand human emotions, beliefs and intentions. For example, hypothetical systems. These systems are envisioned to interact with humans on an emotional level, understanding and responding to human emotions and social cues. The characteristics for the system are understanding human emotions. So, theory of mind AI would be capable of understanding and responding to human emotions, leading to more natural and effective interactions. These systems would possess social intelligence, allowing them to interpret and respond to human behaviors and intentions. By understanding human emotions and intentions, this type of AI could facilitate more advanced and meaningful interactions with humans. Talking about self aware AI, it represents the most advanced form of AI. These systems possesses a sense of self and consciousness. For example, self-aware AI is a concept that has not yet been realized. It represents a future stage of AI. Its development where machines would have their own consciousness and self-awareness. Talking about its characteristics, so this kind of AI would have its own consciousness, emotions, and self-awareness, allowing it to make decisions based on self-reflection and understanding. These systems would be capable of self-improvement, learning, and evolving autonomously. With a sense of self, these AI systems could make complex decisions that consider their own goals, emotions, and experiences. Moving forward, next we have types of AI system based on applications. So there are three types we have. First one is expert system, then natural language processing, that is called NLP, and last we have computer vision. So talking about expert system, these type of systems are AI system designed to emulate the decision making ability of a human expert. They are used to solve complex problems by reasoning through bodies of knowledge represented mainly as if then rules rather than through conventional procedural code. For example, these type of systems like Mycin and Caduceus can diagnose diseases based on symptoms provided by its user, similar to how a doctor would diagnose a patient. These tools can analyze financial data to provide investment advice, risk assessment, and even other financial decisions. Talking about its characteristics. So, the core of an expert system is its knowledge base, which contains a set of rules, facts, and heuristics that represent the knowledge of human expert in a specific domain. This knowledge is organized and formalized to be used by this system. This component applies logical rules to the knowledge base to reduce new information and provide solution to problems. It mimics the reasoning process of human expert. This type of system have an interactive user interface that allows users to input data and receive solutions or recommendations. In addition to factual knowledge, these type of systems use heuristic knowledge, which includes rules of thumb and best practices used by human experts. Expert systems are typically designed for specific domains or problem-solving tasks, such as medical diagnosis, financial analysis, or troubleshooting complex machinery. Next, NLP, which is also known as natural language processing. These type of systems refers to a AI system that enable computers to understand, interpret, and manipulate human language. NLP is used to bridge the gap between human communication and computer understanding. Talking about is examples. So first we have chatbots. AI-powered chatbots can engage in conversations with users, answer questions, and provide customer support. If we talk about virtual assistants, so systems like Siri, Alexa, and Google Assistant use NLP to understand and respond to voice commands. Talking about language translation systems, so these type of tools like Google Translate use NLP to translate text from one language to another, maintaining the meaning and context of the original text. If we talk about the characteristics of NLP, so these type of systems can process and understand human language, including syntax, semantics, and context. This allows them to interpret user inputs accurately. These systems can generate human-like text or speech, making them useful for communication and information retrieval tasks. NLP can analyze large volume of text data to extract meaningful insights such as sentiments analysis, topic modeling, and entity recognition. Advanced NLP systems can understand the context of a conversation, allowing for more natural and effective interactions with users. If we talk about next type of AI system, which is computer vision, so these type of systems refers to such kind of system that enable computers to interpret and make decisions based on visual data. This involves analyzing image and videos to identify object, track movement, and understand scenes. For example, these systems can identify and verify individuals based on their facial features used in security and authentication applications. Self-driving cars use computer vision to navigate roads, detect obstacles, and make driving decisions. Talking about its characteristics, so computer vision systems can analyze images to identify objects, people, and scenes. This involves technique like object detection, image segmentation, and pattern recognition. These systems can process video data, track movements, recognize activities, and understand dynamic scene based on visual inputs. Computer vision systems can make decisions such as navigating a vehicle, identifying a person, or detecting anomalies. Many computer vision applications require real-time processing to provide immediate feedback and actions, such as in autonomous driving or surveillance systems. Next, we have applications of AI system. First point is recruitment. Talking about recruitment is AI can help find the right people for a job, or we can say right people for the right job. It's like a super fast reader that can go through a lot of job applications and pick out the best one. If we talk about language translation and image recognition, so AI can translate languages, making it easier for people who speak different language to understand each other. It can also recognize faces and objects in pictures. Next, we have healthcare. So AI can help doctors find diseases early by looking at medical scan and tests. It's like a super smart helper that can spot things even doctor might miss. If we talk about robotics, so AI can help robots learn and solve problems. For example, robots on assembly line or robots that help teach people new things. Next application is retail. So AI can help stores know what items they need to stock up on and can suggest products to customers based on what they like. It can also answer customers' questions quickly and accurately. Next, we have energy management. So, AI also can do something unique for energy management, or we can say it can help save energy by predicting how much energy we will need at different times and suggesting ways to use less. Next application is transportation. So, AI can help make travel easier and safer. It's used in traffic management systems to reduce traffic jams and in self-driving cars to help them navigate roads. Talking about voice search, so AI can help us search for things online using our voice. This makes it easier to search for information or buy things online, especially when your hands are busy. So there is a case study based on AIS or artificial intelligence system. This case study showcases how a leading online education platform leveraged AI to personalize the learning experience for its millions of users, facing challenges in providing tailored content and maintaining engagement. The platform developed an AI system that analyzed learner data to offer personalized course recommendations, adaptive learning, automated feedback, and proactive support. This resulted in increased course completion rates, improved learning outcome, and enhanced learners' satisfaction. However, the platform also addressed ethical considerations by implementing robust data privacy measures and continuously monitoring the AI system for potential bias. This case demonstrates the transformative potential of AI in education, highlighting its ability to create personalized, effective, and engaging learning experiences. So, here are some questions. I hope you can take a screenshot and solve these questions by your own, although I will discuss these questions one by one. So our first question is, what specific challenges prompt the online education platform to develop and implement an AI systems? So the online education platform was compelled to develop and implement an AI system primarily due to the need for personalization at scale, maintaining learning engagement, and optimizing learning outcomes across its vast and diverse user base. We can say, or we can include few points like personalization at scale. As the platform's user base expanded into millions with a diverse range of learning preferences, career goals, and educational backgrounds, the traditional one size fits all approach became increasingly inadequate. The platform needed a system that could analyze individual learner data and tailor the educational experience to meet varied and specific needs. For example, a professional seeking to upskill in data science would require different course recommendation and learning path compared to a beginner learning basic programming. Another point we can take over here, like maintaining learning engagement. So online learning environments often lack the interactive and dynamic elements of traditional classrooms, which can lead to decreased learner motivation and engagement. The platform needed a way to keep learners engaged throughout their educational journey. This includes providing timely feedback, recognizing achievements, and adjusting learning materials to better suit their pace and understanding. For instance, if a learner was struggling with a specific concept, the AI system could detect this and provide additional resources or simpler explanations to help them overcome their difficulties. We can also take optimizing learning outcomes. So, ensuring that learners not only complete courses but also truly understand and retain the information was another critical challenge. The platform required a sophisticated system capable of delivering adaptive learning experiences that respond to the progress and performance of each learner. This means creating personalized quizzes, assignments, and even offering different teaching methodology based on the learner's performance. For example, a learner who excels in visual learning could receive more infographic based content, while another who learns better through practice could get more interactive simulations. So, these challenges highlighted the limitations of the existing system and underscored the need for a robust AI solution that could deliver personalized learning at a massive scale, enhance learner engagement through interactive and tailored content, and optimize learning outcomes by adaptive to individual capabilities and needs. Our next question is, how did the AI system's capabilities enable the platform to personalize the learning experience for its users? So, the AI system's capabilities enabled the online education platform to personalize the learning experience for its users through several innovative approaches, fundamentally transforming how content was delivered and interacted by the learners. You can see over the slide, like first point we can take detailed user profiling. So the AI system began by creating detailed profiles for each user based on their interactions, courses selections, feedback, and even performance data. This profiling helped in understanding each learner's unique needs, preferences, and learning pace. For instance, if a user frequently enrolled in course related to digital marketing and showed a preference for video-based learning, the AI would prioritize similar courses and content formats in their recommendation. Talking about adaptive learning path, so one of the most significant capabilities of the AI system was its ability to adapt the learning path in real time based on the learner's progress and engagement levels. If a learner was advancing quickly through a course, the AI could introduce more advanced topics or supplementary materials to keep them challenged. Conversely, if a learner was struggling with certain concepts, the AI could offer additional resources, simpler explanations, or even adjust the course difficulty dynamically. This adaptability ensured that each learner's journey was tailored to their individual learning speed and comprehensions. Talking about personalized content recommendation, so the AI system utilized machine learning algorithms to analyze past behavior and predict what courses or content might be of interest to the learner in the future. The predictive capability allowed the platform to make personalized course recommendations that were aligned with the learner's career goals, interests, and educational background, significantly enhancing the relevance of the learning material presented to each user. Another capability we can take automated feedback and support. So the AI was instrumental in providing real-time feedback to learners by analyzing answers and interactions within courses. the AI could identify areas where learners were excelling or struggling. It could then provide target feedback, suggest additional study materials, or even alert human tutors to areas where personal intervention might be necessary. This immediate feedback mechanism helped learners correct their course promptly, enforcing learning and improving retentions. One more capability we can include, that is engagement and motivation tools. AI system also employed various tools to maintain and boost learning engagement. This include gamification, elements like badges and leaderboards, personalized encouragement messages, and reminder based on the learner's activity patterns. By making learning more interactive and rewarding, the AI helped sustain motivation over longer period. So these capabilities, the AI system provide a highly personalized and responsive learning environment that adapted to the needs and behaviors of individual learners, thereby enhancing their engagement, satisfaction, and educational outcomes. This level of personalization was key of scaling the platform's offering while maintaining a high quality of education tailored to each user specific learning journey. So our next question is, what were the key benefits observed after implementing the AI system both for learner and the platform? So the implementation of the AI system brought about several key benefits that significantly enhanced both the learner experience and the platform's operational effectiveness. These benefits can be broadly categorized into improvements in educational outcomes, user engagement, and business metrics. If we talk about for learner, so benefits are very huge or vast. We can take few over here. First one is enhanced personalization. The AI system's ability to analyze individual learning patterns and preferences led to more personalized and relevant learning experiences. Learners received course recommendations and content that aligned closely with their interests, career goals, and learning styles. This tailored approach helped learners feel more connected and committed to their courses, which is turn improved by learning outcomes. Next benefit is improved engagement and retention. So, with adaptive learning paths and real-time feedback, learners more likely to stay engaged throughout their courses. The AI system's ability to adjust the difficulty level and provide supplementary materials as needed helped maintain an optimal challenges level, keeping learners motivated and less likely to drop out. Next benefit is increased mastery of subject matter. So the immediate feedback and personalized support provided by the AI system allowed learner to understand concepts more deeply and rectify misunderstandings quickly. This not only enhanced their mastery of the subject matter but also contributed higher satisfaction with the learning process. If we talk about the benefits for the platform, so the first one we can take higher course completion rates. As learners received a more personalized and engaging educational experience, the platform observed higher course completion rates. This is a critical metric for online educational programs as it directly correlates with learner satisfaction and the perceived value of the platform. The next benefit for platform is scalability of operations. Like the AI system automated several aspects of the learner experience from content recommendation, feedback generation. This automation allowed the platform to scale its operation efficiently handling a larger number of learners without a proportional increase in administrative or support staff. Next benefit is data-driven insights for continuous improvement. So the AI system generates a wealth of data on learner behavior, preferences, and performance. This data was invaluable for the platform's continuous improvement, enabling the development team to refine course material, adjust teaching strategies, and enhance user interfaces based on solid empirical evidences. And the last benefit for platform is enhanced reputation and competitive advantage. So by offering a high personalized and effective learning experience, the platform strengthened its reputation in the competitive online education market. This reputation in turn helped attract more learners and partnerships with educational institutions and content creators. Overall, the AI system's implementation marked a significant information in how the platform delivered education. It not only improved the learning experience for individual users but also enhanced the platform's operational capabilities, paving the way for sustained growth and innovation in the online education sector. Our fourth question is, what ethical considerations and potential challenges did the platform need to address regarding data privacy and algorithmic bias? When implementing the AI system, the online education platform faced significant ethical consideration and potential challenges related to data privacy and algorithmic bias. Addressing these issues was crucial not only for maintaining trust and credibility among users but also for complying with legal standards and ensuring fairness in educational privacy. So we can take so many options here. The first one is data privacy. So data privacy emerged as a privacy concern because the AI system relied heavily on collecting and analyzing detailed information about learners' behaviors, preferences, and performance. This data is sensitive as it can reveal much about an individual's learning difficulties, educational background, and even personal interests. Next point we can take protection measures. To safeguard this data, the platform needed to implement robust security measures such as encryption, secure data storage, and controlled access protocols, ensuring that data was anonymized when used for training the AI models was also essential to prevent any possibility of re-identification. Next point we can take transparency and consent. It was imperative for the platform to maintain transparency about how learner data was being used. This involved clear communication with users about what data was collected, how it was processed, and for what purposes. Obtaining informed consent from users before collecting their data was another critical step in addressing privacy concerns. Next point is algorithmic bias. So, algorithmic bias is another significant challenge, particularly in educational settings where biased algorithmic can lead to unfair treatment of certain groups of learners. If not properly addressed, bias in AI algorithms can perpetuate or even exacerbate existing inequalities in educational opportunities. Last point we can take bias detection and mitigation. The platform needed to continuously monitor and test its AI systems for any signs of bias. This involved analyzing the AI decisions to ensure they were fair and did not disadvantage for any learner. based on race, gender, socio-economic status, or any other irrelevant factor. Techniques such as diversifying training data, employing fairness aware algorithmic, and setting explicit fairness criteria were crucial in mitigating bias. We can take another few points like regular audit, ethical AI use, complementary role of AI. If I elaborate these three, so the regular audit, or we can say conducting these regular audits of the AI algorithmic by independent third parties could help identify and rectify any biases that internal checks might not catch. These audits help maintain accountability and ensure that the algorithms perform as intended without unfair bias. Talk about ethical AI use. So, beyond privacy and bias, the ethical use of AI in education also involves ensuring that the technology is used to enhance educational outcomes without replacing the human elements that are vital for learning, such as teacher student interaction and peer collaboration. And the last point is complementary role of AI. The platform needed to position AI as a tool that complements traditional educational methods rather than replacing them, ensuring that AI tools augment the teacher's role by providing support that allows more time for meaningful interaction with students was a key consideration. Addressing these ethical considerations and potential challenges was not just about avoiding negative consequences, but also about building a sustainable, responsible, and trusted platform that could truly enhance educational outcomes for all learners. You can include more headings or more points in this question according to your study. And our last question is, how can the online education platform further leverage its AI capabilities to enhance the learning experience and improve educational outcomes? So, to further leverage its AI capabilities and enhance the learning experience while improving educational outcomes, the online education platform can explore several advanced strategies. We will discuss one by one. The first one is advanced personalization technique. So the platform can deepen its AI's personalization capabilities by integrating more granular data points such as emotional states, specific learning disabilities, and preferred times of day for study. For example, using AI to detect when a student is feeling frustrated or disengaged and responding with motivational messages or easier content could significantly boost learning efficacy. Next point we can take predictive analytics. So AI can be used to predict future learning paths and potential challenges that students might face based on their current performance and historical data from similar learners. This proactive approach can prepare both learners and educators for upcoming difficulties, ensuring that primitive measures are in place to address them. We can take another point like automated content generation. AI can assist in creating customized learning materials. For instance, based on a student's learning pace and style, AI could generate personalized quizzes and interactive content that address specific educational gaps. This could also extend to a automatic generation of textbooks and resources that are tailored to the curriculum of each course and the needs of each student. Another capability we can take enhanced peer interaction. So the platform could use AI facilitate more effective peer-to-peer learning experiences by analyzing communication patterns and learning outcomes. AI can identify optimal student pairs or groups for collaborative projects, ensuring that group dynamics maximize learning productivity and social engagements. And few more points I can include here, that is real-time performance support. So integrating AI tools to provide real-time assistance during assessment or complex learning activities could significantly enhance learning outcomes. AI could offer hints, reminders, or even step-by-step guidance when it detects that a student is struggling, turning moments of frustration into educational opportunities. Next capability of AI is integration of augmented and virtual reality. So using AI to drive augmented reality, which is AR, and virtual reality called VR applications can create immersive learning environments for complex subjects such as science, history, and art. AI could adapt the virtual environment in real time to suit the learner's pace and learning style, making abstract concepts more tangible or understandable. Another capability is AI driven career pathing. So, AI can analyze job market trends also and the learner's performance to suggest potential career paths and the necessary educational courses to qualify for them. This could be particularly beneficial for higher education students or adults learners looking to change careers or advance in their current field. And our last point is ethical AI monitoring. So, continuously monitoring and updating AI algorithms to ensure they remain unbiased and ethical is crucial. The platform should invest in developing tools that regularly audit and review AI decisions, adapting to new ethical standards and regulations as they evolve. By pushing the boundaries of AI in these ways, the online education platform can not only enhance the effectiveness of its educational offering but also provide a more engaging, responsive, and personalized learning experience that meets the diverse needs of its global learner base. So, that's all about this study. You can learn and you can study on your own and find out the answers of these questions. So, as we discussed the AI systems benefits, application, and even a case study also. So, now you all are aware of the system, so you can better understand the drawbacks of AI system what is. So, there are few drawbacks I have mentioned like higher development cost. So, we will discuss all these points one by one. Let's start with high development cost. So, building AI systems requires significant investment in advanced hardware, software, and skilled personnel, leading to high upfront cost. Right? The next point is complexity and maintenance. So, AI systems are complex to develop and maintain, ensuring they remain effective and up to date with the latest advancements requires ongoing efforts and resources. Next, we have data requirements. So, effective AI systems need vast amount of high quality data for training. Inadequate, biased, or poor quality data can lead to incorrect or biased outcomes. Talking about lack of transparency, so many AI models, particularly deep learning systems, operates as black boxes, making it challenging to understand how decisions are made. The lack of transparency can be problematic in areas requiring accountability. Next, we have ethical concern. So, AI systems can arise ethical issues such as privacy invasion, surveillance, bias, and discrimination. Ensuring ethical use of AI is a significant concern. Talking about job displacements, so automation through AI can lead to job losses in various industries. While new job opportunities may arise, the transition can be difficult for displaced workers. Talking about security vulnerability, so AI systems can be susceptible to cyber attacks and adversarial attacks, where malicious actors exploit the system's weaknesses. Talking about over reliance on AI, so dependence on AI systems can lead to reduced human oversight and critical thinking, potentially resulting in complacency and errors when the AI system fails or behaves unexpectedly. We can mention few more points like environmental impact. So training large AI models requires significant computational power, leading to high energy consumption and environmental concerns. Another point is generalization limitation. AI systems often excel in specific tasks but struggle to generalize their knowledge to different contexts or tasks, limited their flexibility and adaptability. Next is regulatory and legal challenges. So the rapid pace of our AI development often outstrips the creation of regulatory frameworks, leading to legal and compliance issues. If we talk about loss of human touch, so in areas such as customer service or healthcare, replacing human interaction with AI can lead to a loss of personal touch, potentially affecting user satisfaction and care quality. If we talk about ethical use and misuse, so AI technologies can misused for harmful purposes such as deepfakes, surveillance, or autonomous weapons, posing significant risk to society. Talking about bias and fairness, so AI system can inadvertently perpetual or amplify existing biases present in the training data, leading to unfair or discriminatory outcomes. Ensuring fairness and equity in AI decision making is a major challenges. So these were the drawbacks of AI system. I hope you have learned so many things today. See you in next lecture.